Welcome back to another review video. This video will cover section 4.5, the concentration of solutions, molarity, and dilutions. To start with an introduction to molarity. In general, molarity is just a fancy way of saying a concentration. And the book defines the concentration as the amount of solute dissolved for a given amount of solvent. Now, in terms of molarity, this means the concentration of a solution in moles of solute per liter of solution. And we can figure that out using that equation right there, where we divide the mole solute by the volume of solution in liters. Liters is very important. But for example, if we had a 6 molar solution of hydrochloric acid, and the solution, this means that the solution has 6 moles of hydrochloric acid for every liter of solvent, which in most cases is going to be water. Now, try to use this equation. I put it in the top corner for these examples, and then I'll explain them. All right. Let's start with the example on the left. If you take 35 grams of sodium chloride and dissolve it in half a liter of water, what is the molarity of the final solution? So, because in our formula we need moles and volume in liters, we can't use grams. So we have to use the molar mass of sodium chloride, which is 58.44 grams per mole, to determine the number of moles of sodium chloride. And that is 0.599 moles of sodium chloride. From there, we can plug it right into our equation, 0.599 moles divided by half a liter, and that gives us our answer of 1.2 molarity sodium chloride. Then for this example on the right, we had to find the amount of moles of sodium chloride needed to make 2 liters of 1.5 mole or molar sodium chloride. So here we can just go straight into the equation and plug in our values. So we have some number of moles of sodium chloride divided by 2 liters is going to equal our 1.5 molar sodium chloride. From there, we can use some simple algebra and dimensional analysis to multiply that 1.5 by 2 to give us our answer of 3 moles of sodium chloride. So that means we need 3 moles of sodium chloride if we were going to mix it with 2 liters, or if it was going to have 2 liters of volume, and that would give us our 1.5 molar concentration. Next, it's important to consider the concentration of electrolytes because electrolytes, especially strong electrolytes, will break apart in solution. So this means, for example, if we had 2 molar sodium chloride, that means because it's a 1-to-1 ratio in that compound, 1 sodium for every 1 chloride, that it would also be a 2 molar concentration of sodium plus 1 ions and 2 molar concentration of chlorine minus 1 ions. So just on the right side, this is another example. If we had bromic acid in a 6 molar concentration, just because sodium chloride, just like in sodium chloride, it's a 1-to-1 ratio. For every 1 bromine, there's going to be 1 hydrogen. So it's also going to be a 6 molar concentration of hydrogen plus 1 ions and a 6 molar concentration of bromine minus 1 ions. Next, we can also use the molarity and the molarity formula as a conversion factor. And since molarity is just a fun way of saying moles per liter, basically, we can do all sorts of stuff and calculations and dimensional analysis with it. So, for example, if we wanted to know how many moles of HNO3, that's nitric acid, are in a 0.2 molar solution, we would use dimensional analysis and our molarity formula to see if we have 2 moles of nitric acid per every 1 liter, that's what we get from our molar. And we had 2 liters of it, that means we would have 0.4 moles of nitric acid. We can also use this in different ways, saying if we wanted to know the volume of 0.3 molar of nitric acid and needed to have 2 mole of nitric acid, then we can flip-flop our fraction and do 2 moles of nitric acid multiplied by 1 liter over 0.3 moles of nitric acid. So that's 0.3 molar. That gives us our volume of 6.7 liters if this was our scenario. Then we can also do things like if we have 1 liter of a solution that's 5% ethanol, and we know the density of ethanol is 0.789 grams per milliliter, then we can do all sorts of dimensional analysis to figure out that the concentration is actually just 0.858 mole per 1 liter, which is 0.86 molar ethanol solution. Next, dilutions. Dilutions is just mixing one solution with more of the solute, once again, most of the time water, to get a solution with a lower concentration. This can be summed up in the formula I have in the middle there, where if you have the molarity of one solution times the volume of that solution, it will always equal the molarity of a second solution times the volume of the second solution. Excuse me. So for example, if we have 12 molar hydrochloric acid, but we needed 100 milliliters of 2 molar hydrochloric acid, we could plug these values into our formula and do some simple algebra to get 16.7 milliliters of 12 molar hydrochloric acid are needed to dilute dilute our solution so that our final solution is going to be that perfect 2 molar concentration. All right, now I put that formula in the top corner again in case you need it, but here are some examples that I'll explain in a bit. All right, so let's again start on the left. If we have 6 molar bromic acid and we needed exactly 80 milliliters of 1 molar bromic acid, we could, just like the previous example, plug it right into this formula where we have 6 molar bromic acid times a volume is going to equal our 1 molar bromic acid of 80 milliliters of that concentration. So from that, we can do some simple algebra to solve for volume. And when we solve for volume, we see that we need 13.3 milliliters of that 6 molar bromic acid if we wanted to get that concentration. Now, if we wanted to get that 80 milliliters, we have to get that 13.3 milliliters of 6 molar plus however many 80 minus 13.3 milliliters of water, because we also needed to dilute that. So our final volume is going to be 80 milliliters. Then on the right, we have 2.5 molar sodium chloride, but we need 200 milliliters of 0.25 molar sodium chloride. So just like the past two examples, we can plug this into our equation, use some simple algebra. I have the numbers plugged in the equation right there, but just like the other ones, we solve for volume. And we see that volume is going to equal exactly 20 milliliters of 2.5 molar sodium chloride is going to be needed to dilute, it's going to be needed to dilute that 200 milliliters to get it exactly 0.25 molar sodium chloride. So just like the other two examples, we'd also need to add however many more solvent, once again, most of the time going to be water, so in this case, it would be 180 milliliters of water to get our final volume to that 200 milliliters that we want. So our volume would be of our second whatever, it would be 20 milliliters of that 2.5 molar sodium chloride plus that extra 180 milliliters of water. And that would get us our perfect 200 milliliters with our 2.5 molar concentration. All right, that's it. Thanks for listening.